This is video on relative velocity. In this video, we are going to discuss concept as well as some problems. Now, in order to discuss the concept, let's take this example of a truck which is moving in x direction at velocity of 50 meter per second. Now, if there is a man inside that hood of the truck, and that man decides to walk in the direction of the truck at 5 meter per second. And if we put a question that what is the velocity of this man with respect to ground? I don't think it is difficult to see that it is 55 meter per second. Why? Because this fellow is walking inside the truck at 5 meter per second, but the truck itself is moving at 50. So naturally, its velocity with respect to ground is 55 meter per second. Now, in case this fellow decides to walk in the opposite direction of the truck, then what will be his velocity with respect to ground? It will be minus 5 plus 50, 45 meter per second. Because he is walking in opposite direction of the motion of the truss. Now this very problem we can write in terms of vectors. I say velocity of truck is 50i, velocity of man with respect to truck is 5i, and here we can write velocity of truck is 50i, velocity of man with respect to truck is minus 5i. So in both cases, velocity of man, absolute velocity, is velocity of man with respect to truck plus velocity of truck. Now, with this equation, you can really solve any problem on relative velocity. This will be our basic equation. We can write like instead of m, we can say velocity of body A is velocity of body A with respect to B plus velocity of body B, or we can say velocity of body B is velocity of body B with respect to A plus velocity of body A. Let's apply this. Let's apply this to demonstrate that we can solve any problem. First problem goes like this. A ship A is moving northwest at a speed of 18 km per hour and ship B is moving east at a speed of 9 km per hour. Find magnitude and direction of relative velocity of ship B with respect to ship A. So we write this equation. Velocity of ship B is equal to velocity of ship B with respect to A plus velocity of A. Now let's put the velocities in vector form. Velocity of B is 9i, whereas velocity of A is minus 18 cos 45i plus 18 sin 45j. This being northwest, this angle is 45 degrees. So what we get is, we bring these terms on the left side and we get VBA, that is velocity of B with respect to A, is 21.73i minus 12.73j. And that, if of this vector we work out magnitude, it will be 25.18 meter per second at 30.36 degree with x-axis, and that will be in the fourth quadrant. So that will be the velocity of B with respect to A. See, we have just used this one formula. See one more problem. An automobile A is traveling along a straight highway while B is moving along a circular curve of radius 150 meter radius, or curve of 150 meter radius. Fine. From the position shown in the figure, for the position shown in the figure, determine the velocity of A relative to B, and at this instant speed of A is 75 km per hour and that of B is 40 km per hour. So we want velocity of A relative to B. So we write VA is equal to VAB plus VB. This is a vector equation and we put the values. See, VA is 75i, whereas VB is 40 cos 30i minus 40 sin 30j. The reason is, see, when it is in a curvilinear motion, its velocity is always tangential. So 40 km per hour is a tangential velocity it makes angle of 30 degree with horizontal. This follows from geometry. And then you have this velocity of B in a vector form. Bring it on the left side and we get velocity of A with respect to B as 40.36 I plus 20 J, which will be 45 km per hour at 26.36 degree in the first quadrant. This number you get by squaring and adding and taking under root, and tan theta you get by 20 upon 40.36 tan inverse. So this is how you deal with relative velocity problems. Thank you.